In this second Just for Fun video, we'll continue looking at displaying pico memory. You'll recall from the first video, we were displaying a GPIO pad control register in raw format. We ran into one issue quirk with Python, and when it would display a negative number in hex and binary, we got unexpected results, as shown down here. And we fixed it by doing this to get it to come out as we wanted here. We're going to continue looking at that same GPIO pad control register, but now we want to print it in formatted form. Before we leave it here are the print statements for hex and binary without using those interim S and T variables. Now, to do printing formatted, we have to go back to the MicroPython specific libraries. So we go back to docs.micropython.org. We go to MicroPython libraries. Go to MicroPython specific libraries. We had already looked at machine in the last video. This time we're going to look at uctypes. I'm going to click on that. I'm going to scroll down and note this bit right here. A uctype structure is a data structure that looks a lot like a C language struct, where you can break up a chunk of memory into fields and then access it using a dot syntax. There's a warning here about you can read and write using these structures, so you need to be careful because some of the memory we're going to look at are GPIO registers and other fields that the pico uses. So I'm going to scroll down. There's some examples here. We're looking at bit only, so I need to come down to the third example, and this is the example about bits, but it's a little bit too complex for what we want as a beginner. So we're going to keep scrolling down here. We see that we're going to have a structure layout, and the format is a dictionary in Python terms, where you have a word and a value. And the word is going to be the name of the field that we've subdivided our chunk of memory into, and these are the properties that subdivide it. Over here on the slides, I've copied that into the slides. I'm going to continue scrolling down. We're looking for binary, for bit field, and here's bit field, and here's how one of its dictionary entries will look. You'll have the field name and then values like this. Now I've copied that over into the slide, the next slide, so we can leave this now. The bit field entry has a field name, an offset, this thing called BFUINT32, that means a word, 32-bit word, LS bit, least significant bit for position, and bit size for length. And notice these BFs all stand for bit field. We're going to be using 0 for the offset value. If you're going to OR in a value of 0, you're really not doing anything, so we won't specify it. We're going to look at a very simple example first, and then we're going to look at what we came here for, a layout for the GPIO pad control register layout. What we're going to use is a layout of a word to solve that same problem we did in video 1 for the negative number being displayed badly. here's a word layout, has two entries, one called low, one called high. This 0 in light blue is the offset from the least significant bit. The least significant bit is bit 0, and we have an offset of 0, so that means we're going to be using bit 0. The darker blue is the length that we're going to be putting into that low keyword value, 16 bits. This will be the low half of a word. High starts at offset 16 from the least significant bit for a length of 16. That's the high half of that word. And here's how it's used in practice. You set a variable by uctypes.struct. You give it an address. This is that problem address we saw in video 1. And you name the structure that you want to lay on top of that word. And now once you've done that, you can do the print statement much like we did before, but now we do the dot references, so w.high and w.low. Now compare this way with what we did in video 1. Pretty much the same thing. Now we're going to go on and look at the code. And this is for uctypes. We're going to have the same two constants we did at the top of the program 1. Because we're going to again look at GPIO pad control registers. This time we have to have the bit positions of the GPIO pad control register. Here they are, taken from the RP2040 data sheet. Roll it up just a little bit more. And down here is the corresponding uctypes structure or layout corresponding to those bits. Now notice in the documentation the bits were described from high to low. Down here we're describing them from low to high. The slew fast is at bit position 0, so the offset from the least significant bit is going to be 0, so this is bit 0, and it's of length 1 in bits. We proceed on down. Schmidt is at position 1, length 1, PDE at 2, length 1, PUE 3 at length 1, drive at length 4 of length 2, 2 bits, and then IE, OD. Reserved starts at bit 8, offset 8 from the least significant bit, and has a length of 24, goes all the way to bit 31. As a double check, add these up, they add up to 32. We've accounted for all 32 bits. Here's that word layout we saw in the slide. We don't need the slides anymore, so let me hide that. We're going to use that to verify that this does indeed solve the same problem we did in video 1. Now we come to 5 functions. Skip the first one until we look at the second one. The second one we've already seen before. This is what we did in video 1 to do the raw display of a GPIO pad register. Recall that how did that get in here? We set the address using those constants at the top and the GPIO number times 4. And then we displayed it. We didn't worry about the high order bits because they're reserved. Up in this first program, we're going to get one of those layouts for a GPIO pad register. And notice that we do the address the same way we did down in the show GPIO PCR summary, and then we use the layout. Scroll down. Now here are the programs that are going to display the detail. The first one only requires a GPIO number. It obtains one of those overlays and then calls the other one with both the GPIO number and the overlay. The other one immediately follows. It starts off printing a header that just shows the GPIO number and then prints some detail. I'll look at just this first one. What we're doing is working our way from top to bottom. So OD followed by a format, IE followed by a format, drive followed by a format. Recall that drive was 2 bits. And here we have overlay.field, overlay.field, overlay.field. Same for the others. The show word address program is using that word layout to display a word in memory, and we're going to display that problem word again and see that it has the same value. Now we come to the program. Let's take a look at it. And I think I will run it first. There's a lot of output in it, so I'm going to copy it out. And put it where we can see it on the side. Now let's go look at the code. The first subroutine that we run is the one that checks the problem word, and we notice that it did produce the correct value, so it works fine. Following that, we create 3 structures for the GPIO pad control register. One using an explicit address, bad, one using an implicit address partly, but it still has a GPIO pin number specified, still bad. The third one gets one of these structures, just passing in the pin number. This one's okay. We show the summary like we did in video 1, and then we show the detail 3 times using those first 3 overlays, and then lastly we show the detail without passing in an overlay. If you come over here and look, you will see everything looks fine. And we also have a nice look at all the fields, and we can see them, and we see again the pull down resistor is enabled for the GPIO pin. That does it for this video. More to come. Thanks for watching.